Locking down your system there are services by Lennart Poettering. Applauding.
All good? Okay. Hi, I'm Lennart Poettering. I did a talk earlier, so I guess I don't really have to introduce myself. In the earlier talk, I talked about CA Sync, and this talk, I'm going to talk about systemd, like the big project that probably my name is most associated with. The earlier talk was very low level, very technical. This one's going to be more like for everybody, like who administers the systemd system, but also for upstream developers who package service code for the upstream projects. Yeah, I'm going to look specifically about the security features of systemd, and because we added quite a few of those over the last years, this talk is basically a big collection of individually independent little bits that you can turn on for your services that make your services more secure. The stuff that I'm talking about, like, is not an enabler, if you so will, right? Like, it's about increasing the security of your system. And if you're in a hurry, most people don't think so much about security. They just want to solve the problem. So they don't think so much about this, and hence don't use this. It is my intention with this talk to change this a little bit and make you aware that systemd has these security options, and they're really easy to use, and particularly if you compare it with other security implementations like SLinux or whatever, and you really, really should use them. They are opt-in, meaning that you actually have to think about and turn them on, which is unfortunate. It would be much better if they were opt-out, right? So that the services would be secure by default. And if you want to punch a hole, you have to do it manually. Unfortunately, we can't really do that at this point, simply because systemd provides so much compatibility with older versions of itself, and even more importantly, it provides compatibility with System 5 in its scripts and all these kind of things. And on classic System 5, there was no security. There was no sandboxing, no nothing, how the services were separated and isolated from the rest of the system, like the system itself and the other services. Hence my talk. I really try to get into your brain that these features exist in systemd, that they're easy to use, and that you should use them locally on your administrating machine, and if you're a developer in the upstream service files you ship. The central message I want to get across is sandbox everything, right? If you think about containers, nobody knows really what containers are, but in general, people do agree that it's about bundling and about sandboxing, right? Like, the containers are isolated from the rest from the system. They live in their own little environment and don't have access to most of the host system. So with my talk, I try to get the message across. You can do the same thing for system services, and you can do that since 2 years or something, depending on the feature you want to use. And yes, if, for example, you're an upstream developer, let's say you work on Nginx or Apache or whatever, and you turn these things on, then all your users will benefit because we build a more secure internet. Yeah, sandboxing, like, this key is, it's not just for containers, it's also for classic system services, and you really should know that and use it. Yeah, let's jump right in. We have, like, the first option I want to talk about is called private TMP. That is an option you can add to your unit file. Has anybody not seen a systemd unit file yet? Everybody knows? Well, you're lying. So I think most of you have seen that. Like, there are these little ini files where you just write what's supposed to be started. These ini, like, it's an ini file, like Windows-style ini file. It's very simple. Private TMP is one option you can use. You set it to yes or no. It's a simple Boolean. If you, by default, it's off. As mentioned, it's all opt-in. If you turn it on, what happens actually is that the services run like it would normally run, but /temp and /vartemp, which are, as you all know, the temporary directories where programs can put temporary stuff that shall be, like, doesn't have to survive for long. If you do that, then the service gets its own little private /temp that behaves and is located at the same place as it normally would be, but the files placed in there are only visible to that one specific service, right? Why is that interesting? It's interesting because in the history of Linux, one of the major sources of vulnerabilities are DOS vulnerabilities through /temp. The reason for that is /temp is traditionally shared between all system services. So people who are sloppy and unaware of these kind of problems, they are likely to use a guessable name in /temp. Like probably you guys are do that yourself from time to time. I know I do at least, that I go to /temp, create a directory that I call foo and put stuff in there. If you do this, and you're the only user of your system, that may be fine. But if system services do the same thing, right, and other services have also access to /temp, this creates a vulnerability, right? Like, because if you hardcode that you want to have the directory /temp foo, and some other script wants that too, then the permissions won't match and they will interfere with each other, and mostly this will be prohibited, and then you have a DOS because one of the services will work and the other one will not. Private TMP solves this systematically by just saying, yes, you see the file system like everybody else sees, with two exceptions. /temp is going to be an empty directory that only that service sees, and var/temp the same thing. This means you don't actually have to change anything in the source code of the specific servers, and you get the security, like the entire class of problems, it simply goes away. By the way, again, as like in the other one, if you have any questions, completely interrupt me right away. I'd much rather have an interaction going on here all the time than just questions at the end. So if anyone has a question, please show up. There's one. Let's do it with the microphone. It still is.
Please.
Yeah, so basically this private temp flag, does it allow you to somehow share this temp with another service, for example? So like...
Yes. There's actually this other stanza that you can use, and it's called joins namespace off. What you specify there is a service name, and if you do, then both services will share some of the namespaces, including the /temp. So if you actually want to use /temp for data exchange, which I would say it's a bad idea, but knock yourself out if that's what you want. And I mean, there are like classic programs that do this. Like, for example, X11 puts its communication socket traditionally there, which is nasty, but it's API. But anyway, you can do this. Just use this, and then you have two services accessing, or as many services as you want. There's the...
Please.
Where does this private temp actually physically go where it's located? How to make sure it's not 100% filled up and blah 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 stuff, day-to-day usage?
So this stuff is implemented so that what you see from the host is that inside of the real /temp you find a directory that is named after the service, suffixed with something random for the very same security reasons, because you don't want to have guessable names. And that thing will appear as the /temp itself of the service, right? So the data is stored in the same partition and is hence subject to the same quota, whatever you have on /temp, as everything else, right? So yeah, and it's nicely introspectable, because if you're an admin and you want to see what the temporary files and directories are that a specific service creates, you can just go to /temp, look for these directories. They will include the service name. You can look on that. It's very useful for debugging purposes. Okay, let's go to the next one. What I wanted to also mention is, what's really interesting about this is that actually the life cycle of these temporary files is bound to the life cycle of the service itself. This is a really interesting property, because traditionally /temp and var/temp have very unclear cleanup cycles, right? Most distributions, that at least the ones that derive from Fedora and RHEL, tend to clean up /temp and var/temp based on time, right? But Unix doesn't really have a way how you can figure out if a temporary file is an orphan, or if it's still going to be used eventually. So this is always a bit messy, but nowadays it's how people do it. The good thing is, if you use this option, then when the service goes down, this private little subdirectory is also going to be removed, right? So you suddenly, for the first time, have a perfect lifecycle for these temporary directories, and you know that when you run a service foo.service and stop it again, then all its temporary files are gone as well. Yeah, we already talked about this. It's kind of useful. It's particularly useful if you have AF Unix files and sockets and /temp. Joins namespace off is not just for private TMP, it also has other purposes. We're going to talk about this later. Here's another one, completely different security feature. It's called capability bounding set. Capability bounding set simply exposes a concept that the Linux kernel had for a longer time, for a couple of years, like 8 years, 10 years or something like this, in a very easy way. Linux, does anyone not know Linux capabilities? Really, you all know what capabilities are? I'm surprised. Oh, there's one person. Capabilities is something, on Unix systems, you traditionally have user ID 0, which can do anything, and all the other user IDs, which can do much less, right? And this is this kind of binary thing. Either you are fully privileged or you are not privileged. Traditionally, there is nothing in between. Capabilities is the concept to split this up, right? So that all the rights, all the privilege that you get by being root is not something you either are or not, but it's split up a little bit. For example, right now there's something like 36 or something different capabilities, and these capabilities are called, one is called capsys time. If you have that capability, you can change the system clock. If you don't, you can't, right? There's one for configuring the network. If you have that capability, you can configure the network. If you don't, you can't. The Linux kernel defines 36 or something currently of these individual bits. If you have all of them, you're basically root. If you have none of them, you're a normal user. But you can have some of them and not others, right? Capability bounding set is basically a very, very simple way how you can, for a specific service, configure the capabilities it shall have. This is really awesome, because you can have services that run at root without also giving them the full power over the machine, right? Like, for example, Apache, like your web server, is very unlikely to use, to have the need to set the system clock, right? The system clock is something that only NTPD or whatever you use for time synchronization should have, but certainly not your web server. So with capability bounding set, you simply specify capability bounding set equals capsys time. That basically means that that's the only capability it gets, which is what you would use for NTPD. Or you say capability bounding set tilde capsys time, which basically means give it all the capabilities there are except for this one. And then you know for sure that Apache, neither Apache itself nor any of its child processes can ever change the clock. I'm not going to go into too much detail about this. Like, if you want to know, for example, what precisely those 36 or whatever they are currently capabilities are, look at the man pages. Like, actually, for all these options, you should look at the man pages, of course. But it's too much to discuss here in the talk. I hope that makes somewhat sense. Capability bounding set defines all the capabilities that the process at maximum, like the process of that specific service at maximum can ever get. There's also ambient capabilities, which is a way how you can say, these are the capabilities that actually shall be passed to the service, right? This is basically what allows you to run an unprivileged service, right? One service that runs as user foobar, but with additional capabilities that normally an unprivileged user would not have passed. Here, this is the example. I kind of already mentioned that capability bounding set equals capsys time basically means, yeah, run this, but make sure that it can never acquire any other capabilities than capsys time. This is what you would set for an NTPD implementation. So much about this one. If you want to know more about capabilities, by the way, again, are not a systemd concept. They are a Linux concept. Systemd simply exposes it relatively nicely. Any questions about that? Okay, then let's move to the next one. Private devices, super powerful. It's kind of similar to a private TMP, but also totally not. What private devices does, we added this for the reason that most services on the system generally do not need device access. Device access meaning access to dev SDA directly, or dev whatever you have, dev A sound, like the sound card, or dev or serial ports, or whatever else. Most services, like for example Apache or MySQL, generally do not need anything except for dev0, dev null, dev urandom, dev random, and these kind of things, which don't actually refer to physical devices, but simply they are pseudo devices because they refer to Unix concepts like API entry points. They do not actually refer to physical devices like a printer or something that you could actually touch. With private devices, it's again a very simple Boolean. You turn it on for a service, and when you do that, that service will see in /dev its own reduced copy of the real /dev. And this reduced copy only contains dev null, dev random, dev urandom, dev 0, and a couple of more. But there will not appear any dev SDA, dev TTY, dev whatever, anything that refers to actual physical stuff and that might be used for exploits disappears. It's very, very simple, right? You can set this for pretty much everything except for actual hardware device managers, right? So the cases where you don't need this is probably storage manager or something like this. But everything else will benefit from this drastically because raw device access is usually a very easy way to get, change whatever you want, because you can, for example, override file systems and whatever else. Any questions about this? Then let's go to the next one. Private network. Private network kind of is the same thing. It disconnects a service from the network. It's that easy. It's also Boolean. Either you turn it on or you have it off. By default, it's off. If you turn it on, it basically means that the service runs in its own network namespace that, we had a talk earlier where the word namespace showed up very, very often. So I hope you already know what a network namespace is. What private network does, it's basically just a wrap around that. But in a very reduced, minimal way. All it does is creates a namespace, puts the loopback device in, configures it, and nothing else. So if you turn this on, and let's say you have a service like MySQL, for example, then it will see the loopback device, like LO, but it will not see any other network interface, and hence it cannot communicate with anything outside. This is, of course, not necessarily the best idea to turn on for network-facing stuff. Like Apache, you probably don't want to turn this on. But there are plenty of services that are not network-facing that simply provide services for the local machine where you can totally turn this on. It's really, really easy. And of course, it shuts out a major attack surface. Because you know, for example, if you turn this on, like we turn this on, for example, for the logging daemon in systemd, right? We know for sure now that, nobody can come from the network and exploit the logging daemon in systemd, like the journal-d, because, yeah, it has no access to that. It lives in its own little namespace, an own little world where there is no networking. So, yeah, very easy to use. Do use it, especially for stuff that's disconnected from the network. You should never be able to do network resolution. Any question about that? Mike.
Please.
Thank you. For the loopback device that is attached to within this private network, is it still the same loopback device as you have on the whole system?
No, it's not.
Okay.
It's disconnected, and like if you have a little service that wants to listen on the loopback device and has something else to connect to it, it will do that on its own thing, and nobody can talk to it. But I showed this, the joins namespace off thing. I already mentioned this, is also useful for a private network because it actually allows you to run two services in the same network namespace where they actually can communicate like that. So if you have two services that want to use TCP for communication, but they should not be able to connect to anything else, this is what you want to use.
That's ok.
There's a question.
Somewhere here, just a moment.
just about an implementation detail. When you join the network namespace of one of the other services, do you always cache a file descriptor that refers to that namespace before, so you're not doing it by PID?
Yeah, it's pinned. It's a file descriptor that we like.
Okay, so
it's
I'm just
really strange code actually, because Linux is so weird. We actually, for every set of services that uses this, we actually maintain an AF Unix socket, which we use as a buffer to store all the file descriptors in that we need, and then whenever we need that thing, then we take it out of that socket. It's weird code.
Yeah, no, it makes sense. I was just like, the danger obviously is if you do it by PID and the process joins another network namespace in there, then basically you might end up joining a network namespace you didn't really want to join. Yeah.
No, we create the network namespace and then we restore it. Next one, protect home. It's very simple. It protects home. Home meaning like the home directory of the user /home. It's an extended Boolean, as I like to call it. Like, you can use it as a Boolean, yes or no, but you can also give it two additional options than just turning it on and off. If you turn this on, then basically /home becomes unavailable to the service. This is extremely useful because most services don't need access to /home, right? In /home, you have SSH keys and whatever else. So you don't want that Apache, for example, ever accesses that, right? Because that basically means, your administrator key might be accessible to an exploited Apache. So if you say protect home, it will make /root go away, it will make /home go away, it will make /run user go away. It's not visible to the service. If the service, if you actually run code in the service and you look into this directory, you will see a directory that has no access rights, right? It's 000, and it's going to be empty if it's a directory. So it's really useful. There's also the other options, read-only and tempfs. If you use read-only, then /home and /root and /run user will appear to the service, but they will be read-only, right? This is a much weaker protection, but for many cases it's already a good thing too, right? Like, I mean, some servers actually want access to /home, like for example Samba, because it traditionally shares home directories with other systems, probably wants access, but in that case it might even make sense to set a read-only so that Samba can't actually change anything if that's okay with you. And tempfs, if you send it to that, then these directories will appear and they will be writable, but they're going to be empty tempfs initially. This is particularly useful if you actually want the service to be able to write something there, but on the other hand, you don't want to actually make a change to the real home directories, but get its own little fake thingy where it can do whatever it wants, but actually it goes away when the service is shut down. Very easy, totally something you should turn on. And like, for the vast majority of services, you can just turn this on, everything's good. Any questions at that point? There's a question.
Yeah.
Could we not use specifically home, but exclude any other directory? I do it much more flexible, right? Okay. Question is gone.
I think that answers your questions, right?
Thanks.
So philosophically, I think it's really important to make this as easy as possible, right? So I want people to understand that these are a couple of booleans to just turn on. You have the full flexibility. You can use these options: read-write path, read-only path, and inaccessible path. If you do, things become a little more complex, though, because you actually need to know which directory to map and things like that. So that's why we offer both. Internally, it's the same thing, right? This one is just supposed to be so easy. I mean, I can tell everybody this, and they will immediately understand this, right? While the other thing, people might think, okay, how do I do this with wrapping and whatever else, and which ones do I actually want to list there, and things like that. So these ones are idiot-proof, hopefully, one-stop solutions that we can get into the brains of everybody. So this thing. The next one is protect system. Yeah? The mic. Illegal state in configuration, like really.
Here.
Lovely. So what's the strategy for dealing with conflicting or illegal states in configurations?
What do you mean? Like if you use these options and they conflict with each other?
Right. So I could probably do like allow home or whatever it was, no, and then accessible path or read write path.
Oh,
or
you're
whatever
talking
it
about
was.
this one.
Yeah, for example. But I mean.
Okay, this depends. Like the inaccessible path, for example, the inaccessible path, if you can specify any path name there, and then for that specific service, that path will appear inaccessible, meaning it's going to be no access rights and it's going to be empty if it's a directory. If you use this, this will mask out everything else, right? But you can also use like the read-write path and read-only path. On the other hand, is like we reorder them so that they're properly nested. And then the innermost match matters, right? It's the algorithm probably most people would expect how it works, right? So you can basically say read-only pass / and read-write pass / var. It doesn't matter in which order you specify it, but it would always be the innermost wins, which basically means the entire root directory and everything is going to be read-only with the exception of /var because that's what you specified. So we do our best to make the most sense of it, right? Like it's actually really complicated algorithm behind because we have to order things properly and then we mask out bullshit. Like the inaccessible path, for example, will drop a lot of things from the entries. It's a multi-step process to make sure that we honor as closely as possible whatever you write there. Protect system. This is a really important one. This is probably the one I should have started with. Protect system protects the system, specifically meaning it protects the root file system. It has 4 options. First of all, you can consider it a Boolean. If you say protect a system equals yes, the effect is that /user and some other stuff gets mounted read-only. /user being the place where the operating system is stored, right? ls, systemd itself, all those RPMs that you installed put their binary code in /user. And nobody should ever have access to that, like write access to that, with the exception of package managers, right? Apache should not be able to modify your ls binary. If it has the right to do that, it's kind of sad that we are at this point right now where this wasn't protected. So, protected system equals yes, just says, for that service, no write access to /user. You can basically set this for every service that you ever have, with the one exception of package managers, because nobody else should be able to write that. Protect system equals no is the default where this doesn't happen. Protect system equals full is user is protected read-only, and etc is protected read-only too. That basically means that a service set up like that can neither modify your binaries nor your configuration. Very often that's the better choice actually, because most services should not be able to change their own or other services configuration. This, of course, is something you cannot set for software that's supposed to reconfigure as a software. And then finally, there's protect system equals strict. This is actually the one that I tend to use for all my stuff by default. It just means everything's read-only, with the exception of /run and /var, right? It basically is the most strict one, where basically everything in the top-level directory and the root directory is also protected. This is really something you should totally use for all your services. But as soon as you use protect system equals strict, you have to whitelist everything you actually should be able to write to, right? It inverts the default behavior. Because in classic Unix, you could write everywhere. If you turn protect system equals strict, you basically can write nowhere. And if there are directories you want to be able to write to, you need to list them explicitly, for example, with read-write path. Any questions about this? About what?
TMP with strict.
Yeah, protect system, like these options. The question was regarding what about /temp with protect system. What's important here is the 3 options that I just, or 4 options that I just explained. Private devices changes /def, private TMP changes /temp, private protect home changes /home. And this one, the root directory, the idea is always that these individual options override what protect system strict does, right? So protect system will basically control everything except the 4 ones that we talked about earlier. Or it's actually 5 ones. Any questions? By the way, my slides for the rest of the time, we'll just go through these options, right? So I have the suspicion we're not going to finish all the slides, but that's entirely okay, because hopefully these slides will show up on the internet and you can read the other ones. I just have these slides so that if you don't have any questions, I can keep talking until everybody falls asleep. So I'm just saying, it's completely okay if we don't
I see
cover
one
everything.
hand. Sorry. Someone have just frightened and decided to ask something.
Yeah, because actually I'm impressed. I would like to maybe use a good half of that in the firmware I'm building, but firmware is not perfect. So I would like to use the protection 90% of the time, but I would like to lower the barriers during the firmware upgrade. So how would you suggest I solve that?
Well, that's a good question. Like what systemd actually allows you is that systemd has a scheme where unit files can come from a vendor, right? And then the idea is that local administrators might want to override specific settings, might want to unset them, maybe change them, maybe extend them. So in systemd we have this concept where you have drop-in files that are read after the vendor supplied original unit files. So you could use that, right? But instead of being vendor and admin, it would be both sides you, where you provide the default vendor file with the full protections turned on, but when you do your firmware upgrades, you drop in temporarily one of these drop-ins, like these extending drop-ins that modify a couple of these things in your specific way. And these drop-ins, you can actually you can drop them into either etc. In this case, they are a persistent configuration, but there's also a matching directory in /run. When you drop it in there, it will honor it as well, but then it's not persistent because /run is a temp, and then on reboot it's going to be lost. So in your case, you probably want to stick it in /run, and it will extend the unit file. Read the systemd man page about drop-in unit file extensions, and then you hopefully get the idea what I was just talking about. Okay, next one, private mounts. This one is, so most of the stuff that I was talking about earlier, with the exception of the capability stuff, is actually implemented based on mount namespaces. Mount namespace, everybody of you knows what it is because Christian Brauner talked about this in all detail earlier about namespaces. Private mounts, like if you use any of the earlier options, it will implicitly turn on a mount namespace. This has effect. This has the effect that if you live in your private mount namespace, if your service actually intends to make mounts, it will not propagate to the system, right? Because in order to be able to make these changes to the file system layout for that specific service, it has to be in its own private mount namespace, but that means that not only the mounts that we establish will be active specifically for that service, but everything that the service itself later creates too. Sometimes that is not a desirable thing. In that case, you cannot use any of the options that I explained. Sometimes you want to have just this thing without all the other ones. In that case, you can use private mounts. What that does, it makes no other change than create its own mount namespace. It will not do private TMP, will not do private devices or whatever else, but it will create a mount namespace of its own. Yeah, we talked about this already. This is more low-level options where you can actually specify a specific path. And as mentioned, it's relatively smart, so you can specify as much as you want, and then we'll reorder and put them all together that it makes the most sense, so that the most inner path access restrictions actually apply. There's, by the way, a fourth one that has recently been added. It's temporary file system. If you use that, you can specify a path, and then this path is going to be replaced with a temporary file system that's only visible in that service's namespace, and then when the namespace is restarted, it automatically gets flushed out. It's kind of useful for the same use case that I mentioned earlier, where you want the service to allow to write to some directory and do changes, whatever it wants to make changes, but that it doesn't have any effect on the rest of the system, and it's automatically cleaned up when the service goes away. Any questions so far? Otherwise, we're gonna go to these three things. Systemd integrates relatively nicely with the different kinds of Macs. Different distributions tend to use different Macs, like Macs as an mandatory access control. Like Fedora implements SLinux. Ubuntu implements UpArmor, Tizen uses Smack, so everybody uses something different. In systemd, you can specify that for the service individually. I'm not going to talk too much about this because if you fully want to understand this, you have to understand these Macs, and that's usually not that easy. And more importantly, the message I really try to get across is that the options, most of them that we have, are really easy to use because they're just Booleans, and this makes it more complex. But I just want to make sure that you're aware that these things exist. Here's another one. No new privileges. That's not a systemd thing, it's a kernel thing, but we expose it in systemd. It's a Boolean that you can set for a process, and that is inherited for all child processes of that process. What it does, it turns off SUID binaries, right? I'm pretty sure all of you know SUID. Does anyone not know what a SUID binary is? A SUID binary is something like on traditional Unix, if you're an unprivileged user, like for example, I'm user Lennart, I want to be able sometimes to execute more privileged code. For example, the most well-known example is ping. You know the ping command? The ping command actually creates raw sockets, or actually it doesn't anymore, but it traditionally created raw sockets to be able to generate these ping packets. And raw sockets, because they're extremely powerful, are only accessible to root. So how did they solve that? That I, as an unprivileged user, can do a privileged operation in that program? The answer to that is setuid binaries. Setuid binaries basically say you can mark the executable in a special way. Only root can do that, and it basically says, run this thing, but become root while you do that. And the kernel honors that, and it's a traditional way how you can acquire privilege that you didn't have before, right? Nowadays, there's a movement that thinks that doing it this way is probably not the best idea. I'm among those people. But it's a change from traditional Unix philosophy. No new privileges allows you to, for specific services, opt out of this traditional way how Unix works. If you set it, it basically means setuid, and actually file system capabilities, which are very close to this, will lose their magic powers, right? If you set this for a service, and that service calls ping, it doesn't matter that the setuid bit was set on it, it will still not run at root, but under your user ID, right? So it's an extremely powerful thing, because if you set it for a service, you basically know that this service and any code that might be smuggled into the service because it's exploited can never acquire privileges again anymore. It doesn't come without problems, though. One of the problems is if you use a distribution that uses SLinux, it doesn't really work, because SLinux, every execution that you do changes the label, basically, depending on who does it and so on. And no new privileges turns this off, so it kind of conflicts with SLinux. It's still extremely useful on all the other distributions that do not use SLinux. So yeah, if you use it on Ubuntu or Debian, you should be completely fine. And it's a major step ahead to make things more secure. Yeah, problem is SLinux. Any questions so far? Okay, the next one is called system call filter. System call filter exposes something that you might heard is all the rage on Linux currently with the developers at least. It exposes something called seccomp, secure computing, or BPF you might have heard, which is kind of related to this. System call filters is a scheme how the set of system calls that a service can execute, the process of a service can execute, can be limited. A system call, just for those who don't know, is this primary way how user space communicates with the kernel, right? So if you open a file, for example, your user space program invokes the open system call, asking the kernel to do something, look it up on disk, do I/O, whatever it needs to do, and then return a file descriptor, right? Like, so it's a system call is a gate into the kernel, and then eventually return from the kernel. Because system call filters are at this really important boundary between user space, between potentially unprivileged, untrusted code, and the kernel side of things, which is highly trusted, which has all the privileges of the system, people have always been interested to limit the exposure. Because if you limit the system calls that are accessible, currently in Linux we have like 500 or something, 600 system calls. If you limit which system calls a process can execute, you can drastically minimize the attack surface that exploited code can use. So system call filter as its most basic is you just list system calls there. Like here's, for example, an example. If you say system call filter equals tilde key control, what this means is just the process of the service can execute any system call they like, except for the one system call called key control. Like the tilde always means inverting behavior in systemd, because systemd will allow you two things. It allows you to whitelist system calls and to blacklist system calls. Whitelisting system calls basically means you only list the system calls that the service shall be able to call. Blacklisting means you list the system calls that the service is not allowed to call. If you specify the tilde, it becomes a blacklist. So this expression just means execute whatever you want, but not key control. Key control is access to the kernel keyring. The kernel keyring is basically where you can tell the kernel secret data. And by doing this, you basically take away quite a big attack surface, because you know that any service executed like this cannot read or write kernel secret key material. So this is very simple. Usually, though, it's much better to work with whitelists than with blacklists, right? This is the blacklist as mentioned. Usually, it's much nicer to just say what it can do instead of what it can't. There's a question?
A question. Great. By the way, we have a little bit late, but it's not a tragedy, I think.
Sorry, what was that? How much time do we?
I wanted
no, that
to say that we are a little bit late in time, but I think it's not a tragedy.
Yeah, I mean, we can finish any time. Like, it just goes on like this.
All right, thank you. For the system calls, does systemd provide any way to actually, right now, this is some kind of unknown service, but I want to basically make a list of the system calls that I can later put it there to whitelist them?
Yeah, that's a very good question. Like, the tools around seccomp for that are not that great. Like, I mean, at least systemd won't give you much help with that, like figuring out which system calls there are. One tool that you can use is strace, right? Strace lists the system calls executed. But of course, ultimately, I figure the right set of system calls to call is probably something that the original developer has to figure out, because he knows which APIs he used. There are, like, auditing helps you too, because with auditing, you know, like the audit subsystem of Linux also allows you to trace system calls. The SLinux people have something for this. Systemd does not provide anything like that. There might be tools that I'm not aware of that help you with this kind of stuff, that simply trace this. But I couldn't tell you. Like, I mean, there are other people who do SEP. Do you know a tool, like either of you? Christian? Anything? Okay, so he said the Docker people are working on something, and other than that, strace. So.
Right, thank you.
Two more questions.
Hello. What will happen if we ban exit syscall?
If we
Exit syscall.
If we exit what?
If we ban exit system call.
If we exit system call?
System call and
Oh, that's it. Yeah. So what actually happens if key control is executed? Because I was stupid, the default behavior is actually that the process is going to be terminated. I don't think that's a good default behavior. I'll grant you this much, but it's difficult changing defaults. There's another option. It's called system call action or something. I don't even know how I called it. Look it up in the man page, and it basically allows you to say what shall happen. It can mean that it shall be aborted, but probably what we should have done as a default is that we return the eperm error, right? So that the process, when it invokes key control, gets a clean error back from the kernel, which says, this is not permitted, go fuck yourself.
Can I? I have a broad question. If there is any activity to allow running regular applications in this manner, so that they have their own control group, and such restrictions can be applied to them. For example, if I want to run some proprietary application and describe its access limits
Okay, so,
Like-
so you're looking for something where you can make use of all this restriction stuff, but not necessarily as a service, but simply
Yes.
as a separate command and
Inside
possibly...
user session, launching a regular application.
Okay, so
Like desktop
that's a good
file.
question. So there are multiple projects like this. With systemd, systemd does not provide this for you, right? It does provide you something related though. There's a command called systemd run. Systemd run is a way how instead of predefining a static service file and dropping it at etsy, you can instead put together a service on the command line, right? So this basically allows you to execute any command you like under systemd supervision. And if you do that, you basically have the option to do systemd run -p, and then you can specify any of these options, like system call filter or anything else I talked about, and lots of other stuff. And then you specify a command line, and then this command line will be executed, and you'll get the output and whatever else, but it will be executed under systemd supervision and with all of this stuff applied. So it's basically an extremely dynamic way how this functionality is exposed that is normally in a static unit file. It's kind of nice, actually. Like, people should really know about this because it's super powerful. You can even, like, if you're a Unix guy and you like to build shell pipelines, right? You can even, it's so powerful that you can say, yeah, I'm cutting that file and then I'm piping it to systemd run to a command that is then executed under resource managed and security managed as a systemd service, basically. Then it gets this data and then eventually pipe it out and do something else with it. Like, this is, for example, interesting if you, I don't know, you do FFmpeg or whatever, and you know that the FFmpeg, many of the codecs are not the highest quality code in the world because they're written by multimedia engineers and not by real hackers or something. I didn't say that, but it's a very efficient way where you can basically sandbox things down very nicely because you don't have to trust FFmpeg anymore, because you can say basically, yeah, FFmpeg, you can do math, but you can't do file system access, and you can't do that and that and that, and then, yeah, you can build your pipeline very, very nicely. It's a super useful tool. It's something, I probably should do a talk about its own, about systemd run, and its many, many uses of awesomeness. And it's, yeah, I hope that answers the question. But, I mean, there are other people who've wrote something like FireJail or something. Then the people from GNOME have something called Bubble Wrap, and they all are more application focused, so that if you are an unprivileged user, like a regular user, that you can lock out stuff in a more protective way. I know, for example, that the GStreamer people are working on sandboxing their own decoders, like my FFmpeg example, because they also don't trust the codecs and things like that. So there's lots of work, but I'm not the right one to answer that question because I work on systemd and not on those other things. But Google search should help you to find these.
Thank you.
I don't have much time. Let's finish this.
Well, maybe we had normal finish 11 minutes ago.
So let me just finish this one slide. Yeah, this is another example, the third line here, which is the whitelist. I talked about the blacklisting, where key control is blacklist. This is the opposite way. We simply say these are the ones system calls that shall be able to use. Because there are so many system calls, like 500 or something, it's very difficult to know which ones you want. To make this easy, in systemd we have grouped many of them together. And if you can reference these groups instead of the individual key system calls, it's completely up to you. Like in this case, for example, if you use that line, we have this group called system service. A system service is something that we figured out is a common set of stuff that most system services will probably need, and that is relatively riskless. So my recommendation is always, if you lock down your service, use add system service. Then add on top whatever you need. Like, for example, if you want to do something that can create system timers or something like that, and as a system service, just specify the groups and you're done. Okay, since the time's already over, that's the last thing I'm going to say. Can we take one or two more questions? Otherwise, thank you very much. Do we have time for one, two questions? Oh, and are these slides going to show up on the website? I hope so, right? Yes. Okay, then like, there are more, right? And it goes on like this. And it's completely fine that we didn't do that. Like, much preferred that we had the interactive communication here. But if you need more inspiration about what you can lock down in your service, just go to the website and look at the size, and then you have a couple of ideas here. And if you want to know more details about every single one of them, look at the man pages. And that's really all I have to say, except if we have no more time for questions.
Have we finished with all our questions?
I mean, if nobody
I think yes. At least we had a lot of them.
Excellent.
Thank you, Lennart.
Thank you.
It was our last talk for today.